Hello and welcome to Unit 2, Lecture 1 for Introduction to Logic. This unit we're talking about something called derivations. And derivations are a way of showing that an argument is valid. And it's going to replace the notion of truth tables. So we can use some truth tables to tell what an argument is valid. But there are two problems with truth tables. The biggest problem is they grow in size exponentially. They get super big, super fast. So if there's 6 different letters in an argument, that means you need 64 rows. Doing a 64-row truth table is really annoying. The other thing that's a disadvantage of truth tables is they're not really the way we ordinarily think. If I'm trying to think, oh, is this way of reasoning valid? I wouldn't ordinarily think, well, what are all the possible combinations of truth or falsity I can assign to the statements in this? Let me do a chart in my head. No, that's not the way we actually think. So we're going to try to do a new method of showing an argument's valid. It's based on the idea of step-by-step reasoning. So consider this form called modus ponens. If A, then C. A, therefore C. That way of reasoning is obviously valid. Everyone who reasons that way can tell that that's valid. Now let's consider this more complicated form. If A, then B. If B, then C. If C, then D. A, therefore D. This argument isn't exactly of that form, but it's not quite as obviously valid, but we can see how we could break down the reasoning in this argument into a series of steps, each of which is a modus ponens. Since I know if A then B and I know A, I can conclude B. Now that I know B, I already knew if B then C, that was one of my premises, I get C. Now that I've concluded C, since I have another premise that says if C then D, I can conclude D. So what I've done is I've taken this argument here and I've broken down the reasoning behind that argument to a series of steps. Each step is a modus ponens step, and each step is obviously valid. We call this way of doing something a proof, because we prove the conclusion from the premises with a series of steps of reasoning, each of which is obviously valid. Technically, we also call them derivations because we're going to derive the conclusion from the premises. So start with a method called direct derivation. Suppose we have an argument like this, if A, then B. We're going to have a way of writing up a step-by-step chain of reasoning that shows this argument to be valid. We start by writing every premise down with the letters PR next to it and numbering the premises. So premise 1, if A, then B. Premise 2, A. And then we're going to write down another line for the conclusion, but rather than writing down the conclusion just as it is, we're going to write the word show before it to indicate this is what we're trying to derive. We're going to take 1 and 2, and from 1 and 2, we're going to try to derive, we're trying to show that B is true. Over to the right, we're going to use the method we're going to use for showing it. Today's method is called DD for direct derivation. That is just using direct rules of reasoning. We're going to reason from those premises to this conclusion. So underneath this, we're going to, inside a box, these dotted lines represent where we're going to draw our box. We're going to show the steps from which we get from A to B. We're going to indent those steps slightly so we have room to draw the box afterwards. So you see our first step, 1, if A, then B, line 2A. By modus ponens, that gives us if A, then B. Right? So line 1, if A, then B. And line 2A, we get if A, then B. Over on the right, we're going to write our justification for writing down those two, this new step of reasoning. So 1, so we use line 1, 2, because we use line 2, and arrow out, arrow O for arrow out. The modus ponens is going to be abbreviated as arrow out. A way of using an arrow statement is called arrow out. So modus ponens is one of 2 ways of using an arrow statement. We'll talk more about why it's called an out rule later on and why we abbreviate modus ponens as arrow out. So we get this from these 2 lines by using this inference rule of modus ponens. 1 and 2, we write the 2 lines that it came from and the rule we use to get it. Now we can move on to our next step. So now we have if A then B. Line 2 says A. If A then B and A, we get B. So line 5, we're going to write down B. We're going to write the two lines that this came from. It came from line 2, A, and line 4, if A then B, we get B. So it's the same rule of modus ponens, so we're going to abbreviate that again as arrow out. We write 2 and 4. Now that's the thing we're trying to show. Once we show the thing we're trying to show, we're going to cross out the word show and draw a box around the two lines we used to show it. As we've succeeded in showing B, we'll cross out B and write if A then B. Each line of the derivation is annotated with how we came to that line, the rule we used and the lines it came from. Now we can't use the show line, so notice that line 3 is never appealed to here. You can only use the lines that you're given. Show line, until the word show is crossed off, is not something you can use to get your show line. That would be circular. You can't use what you're trying to show it. You have to use the other lines to show the thing you're trying to show. All right, let's just do that first argument in the same way. So I'm going to click to show it, try it yourself. So the way this will start out, when you do it on the computer, you'll have each of the premises written down with a line number, and the word PR for premise over on the right, saying the reason I wrote that down is because it's a premise. Then you'll have a show line, the word show written down, along with the thing you're trying to show. So we're going to show D from if A then B, if B then C, if C then D, and A. The first thing you do is in this box over on the right of the show line, you're going to write the method you're going to use to show it. The method we're learning today is called direct derivation. It's abbreviated DD. So for today, we'll just write DD for all our derivations. DD for direct derivation. That just means we're going to directly get the show line from the premises. Now we're going to put in a new line for each. So click the new line button, and a blank will pick up where you can put in the next line. So the first step of reasoning we can do is from line 1, if A then B, and line 4 we have A. So we get B, if A then B, and A, we get B. So over on the right, there's another field here. You write 1, comma, 4, arrow, O for out, arrow out. If you need to change the thing you wrote down, you click this pencil, and you can change what you wrote down. If you need to delete something, you'll click this X here to delete a line. I don't need to change that. Click this pencil to change what you wrote, what you put in. If you put in something that doesn't make sense, it'll give you question marks, and then you'll need to change it. Now that we have B, our next step is from if B then C and B, we get C. So I'll put in C in the next line, and I'll write the two things that came from over here on the right. That came from line 2, if B then C, and line 6, B, if B then C, lines 2 and 6, arrow out, you get this. In addition to typing arrow out, you go click over here. If you hover the mouse cursor, I don't think you can see my mouse cursor, if you hover the mouse cursor over one of these rules on the right, it'll show you the rule. If you click on it, it'll put it into your problem on the line you're working on. I'm going to get rid of these rules of derivation because they take up a lot of room, and go back to where we are. So now we need a new line. I've got B and I've got C. Next thing I can write is D. That's going to come from line 3 and line 7. And again, the rule is arrow out. I'll type in arrow out this time. You can also click on these line numbers to put in the line numbers over on the right. Now, when you get a line that's the thing you're trying to show, you can cross out the word show. The way you cross out the word show in the computer is just to click on the word show, and it draws the box for you. So you get a box around the lines you use to show it. That's your derivation. And you want to click check derivation to see that you did it correctly. If you did it correctly, it'll turn green. You can also check the individual lines, and if they're all correct, you'll get a check mark next to those lines. All right, let's do another one. I'm going to skip this one. I'm going to do this one here. This one looks really complicated, and if you do a truth table for it, you get 3,584 T's and F's because you need 128 rows and 28 columns. That would be a nightmare. It still looks really complicated, but if you break down the reasoning to just modus ponens, it's actually not too difficult. So we have 5 premises. If P or Q, then R, if and only if S. If T, then if P or Q, then not M. If not M, then if R, if and only if S, then N. T, P or Q, show that N is true. So first thing we'll do is write direct derivation over here on the right and click new line to get a new line. First thing we can reason from is line 1 and 5. So modus ponens applies not just when the if then and the if part and the then part are simple statements, but also when they're complex statements. So notice that 5 is the if part of 1. If P or Q, then something. That's what 1 says. So we get R, if and only if S, from 1 and 5 modus ponens. 1 and 5 arrow out. Line 2 says if T, then something. We have T at line 4. So if T, then, you get the whole if then part of 2. That's the whole if then part of 2. It comes from 2 and 4 modus ponens. Now we can't do anything with line 3 yet by modus ponens, because through modus ponens we need not M. But if you look at line 8 says if P or Q, then not M. We have P or Q at line 5. So from 5 and 8, we can get not M. 5 and 8 modus ponens gives us not M. Now that we have not M, we can use line 3. So line 3 says if not M, then this whole thing. So we get this whole thing. If R, if and only if S, then N, from 3 and 9, arrow out. If R, if and only if S, then N, we have R, if and only if S at line 7. So from 7 and 10, we get N. That's the thing you're trying to show. So when you show the thing you're trying to show, you click on the word show, draw your box, and then click check derivation to make sure you did it correctly. So that was maybe something that you think of as fairly complicated, but believe me, it's much easier than doing a truth table for that argument. All right. So the idea behind a derivation is to break an argument down into a simple series of steps. So one kind of step you can do is modus ponens, but there are other kinds of steps you can do that are also fairly obviously valid. So the first two we're going to learn, we've already learned half of it, are rules for using an arrow statement. Rules for using or breaking up an arrow statement are called arrow out rules. We've already learned one of those rules, modus ponens. The other one is the one here on the right. It's called modus tollens. Modus ponens means affirming mode in Latin. Modus tollens means denying mode. Let's look at the second one, modus tollens. If A, then C. Not C, therefore not A. So here's an example of that kind of reasoning. McCavity stole the diamonds, and McCavity's hair was left at the scene of the crime. And McCavity's hair was not left at the scene of the crime, therefore McCavity does not steal the diamonds. If A were true, C would have to be true, but C isn't true, so A can't be true. That's called modus tollens. You can also use modus tollens. It's also abbreviated as arrow out when you do a derivation. So let's try it in this particular argument. If X is true, Y is true. If Y is true, Z is true, but Z isn't true, show that X isn't true. This is still direct derivation, so I'll write DD in this box for the show line. Then I'll click new line to get a new box here. Now I'm going to reason from 2 and 3. 2 says if Y were true, Z would be true. The 3 says Z isn't true. So in modus tollens, I get that Y isn't true. From 2 and 3, modus ponens and modus tollens are both abbreviated as arrow out. Now I can use line 1. If X were true, Y would be true. But I've just gotten that Y isn't true. So I get that X isn't true. That comes from line 1 and 5, modus ponens. Now I've shown the thing I'm trying to show, so I can click on show, cross off the word show, and check my derivation. Let me do one now that uses both modus ponens and modus tollens. If A, then B. If not A, then C. Not B. Show that C. Again, this is all direct derivation, so I'll write DD in this field over here next to the show line. First thing I can do is line 1 and 3. If A were true, B would be true. But B isn't true, so A can't be true. So I get not A from 1 and 3, arrow out, modus tollens. Now, not A is the if part of 2. So if not A, then C by modus ponens on 2 and 5, I get that C is true. Because again, the if part doesn't have to be simple when you do modus ponens. It can be something complex, but we have the exact statement. That's the if part of 2 at line 5. So 2 and 5 modus ponens gives me C. Cross off the word shoot, cross off show, do my derivation. All right. This next one's kind of tricky. If not P or Q, then not S. If S, then not S. S, show not P or Q. Do this by direct derivation again. First thing we can do is lines 1 and, we can't do anything with line 1 yet, but you might think line 3 is the opposite of the then part of 1. But when you look at the rule of modus tollens, it's if A, then C. Now these fancy cursive letters are placeholders for anything simple or complex. We have to plug in things uniformly for the A and the C. So I put in S for C. The other line I have to have is not S. If I put in not S for C, the other line I have to have is not S. I don't have not S yet, so I can't do modus tollens with line 1. First I have to do modus ponens with 2 and 3 and get not S. 2 and 3 modus tollens gives me not S. Now, not S is the negation of the then part of 1. To do modus tollens, you need the exact negation of the then part of your if then. If the if part's also a negation, though the if part of 1's a negation, what you get is a double negation. So we get not P or Q. So think of this A here is not P or Q. What you get is not P or Q. Luckily, that's what we want. So that's from 1 and 5 modus tollens. You can't do modus tollens with 1 and 3. You can only do it with 1 and 5. You need the exact negation of the then part. And what you get is the exact negation of the if part. Later on, we'll learn a rule called double negation for eliminating and introducing double negation. But for the moment, you got to make sure when you do modus tollens, you need the exact negation. Oh, I typed in 1 and 6. It should be 1 and 5. Cross off the word show. That's what we were trying to show. Check our derivation. This should be okay. Okay? So that's modus tollens. We're going to learn one more rule today, or really two versions of this rule. Just like there are two versions of arrow out, there are two versions of the next rule we're going to talk about. This rule is called wedge out, or out. And it's a rule for using or breaking up an or statement. If I know A or B is true, but I know not A, I know B has to be true. If I know, the other version goes like this. If I know A or B is true, and I know B is false, then A has to be true. If I know an or statement, I know one of the two sides is false, the other side has to be true. That's called wedge out. This is exactly the kind of thing that Sherlock Holmes does, right? If it's either Jones or Smith, but it's not Jones, it has to be Smith. Either the U.S. team will win the gold medal or the Canadian team will win, but the U.S. team won't win, the Canadian team will win. It's also called modus tollendo ponens. I'm not going to make you learn that. We're going to call this wedge out, or O. So a simplest kind of thing like this would be this, direct derivation. U or C, United States or Canada, not United States, therefore Canada. We get C right away from 1 and 2. Rather than writing arrow out now, I write or out for wedge out. So let's do it in a more complicated one. Nope. If not L and H or S, L and H or P if and only if Q, not S, so P if and only if Q. So one says either this or this, but 3 says not the second thing, so we get the first thing. Like direct derivation for direct derivation, so we get the first thing being true. The first thing doesn't change. If it had a not in it, we'll leave the not there. 1 and 3 wedge out. Now that line 2 says either L and H or P if and only if Q. We know it's not L and H now, so we get P if and only if Q from 2 and 5 wedge out. Okay? We can also do problems where we use both modus ponens, modus tollens together with the other things we're going to learn. So let's do this one here. So we use both arrow out and wedge out for this. So again, DD for direct derivation, that's all we're doing today. If P, then if Q are either if Q then R, or S, not S, if not S then not R then P. So we can't start this with line 1 because we don't have P and we don't have the negation of the then part of 1. But we have not S, and if not S then not R, we get not R and modus ponens from 2 and 3. So that's arrow out. We're using the arrow rule. Now if not R then P, so we have not R now, so we get P from 4 and 6. You actually click the line numbers, 4 and 6, to put in the line numbers over here. It doesn't matter what order you put them in. Arrow out for arrow out. So now we have the if part of 1. If P, then either if Q then R or S. So we get either if Q then R or S from 1 and 7, arrow out. Now I have an either or statement at 8. If I can rule out one of the two sides, I know the other side has to be true. If Q then R or S, I have not S at line 2, so I get if Q then R has to be true. It's either if Q then R or it's S, but it's not S. So that's 2 and 8. Wedge out that time. Now if Q then R and I have not R at line 6, I get not Q by modus tollens on 6 and 9. 6 and 9, arrow out, gives me that. Now I've shown not Q, I cross off the word show, check my derivation. I like to do a dance when I get these right. It's kind of like a football. You have to, every down you move closer to the end zone. When you finally get to the end zone, you can cross out the word show. You have to celebrate a little bit, do a little dance. Can't do that on the computer though. Here's some pitfalls I want you to avoid. Don't confuse modus ponens and modus tollens with this. If A then C, C therefore A. The arrow goes from left to right for a reason. If you don't have negations, you can't go from right to left. That's not valid. If A then C, if not A, therefore not C, that's not valid. Don't use that. If you have negations, you have to go from right to left. You can't go from left to right. And with or, you have to have the negation of one of the two sides. You can't have the side as is. If you have the negation of one of the two sides, you get the other side. But if you just have one of the two sides, you can't get the negation of the other side because this is the inclusive sense of or. It could be that both A and B are true. So I know A or B and I know A. I don't know not B. These are invalid rules. Don't use any of these rules. Another pitfall you have to avoid is applying rules to parts of lines. When you do arrow out, the arrow statement you're applying arrow out to has to be the main operator of the line. You can't apply the rule to part of a line. So if I have P arrow Q or R and I have not Q, I can't do modus tollens to just the P arrow Q part of this line. The only rule I could use for this line is wedge out. You have to use the rule for the main operator. You can't apply the rule to part of a line. And the not Q isn't the negation of the whole or statement, or the half of the whole or statement. So you can't get R from this either. You can't apply not Q or R, that part of that since the parentheses will make this the main operator is or. You need the negation of the entire half of the or statement to apply wedge out. All right? So you have some homework where you do these using these two rules we learned today, arrow out and wedge out. Hopefully you can do those now. And thanks for listening.